Hello students, welcome to Educate. In the last class, we have discussed why the nucleophilic substitution reaction in haloarene is difficult. And I have informed you that the nucleophilic substitution reaction in haloarene is difficult, but that does not mean that the haloarene don't react with nucleophile. Actually, there would be reaction, but the reaction will be in adverse condition. As for example, when, let's see example here, when this haloarene react with NaOH and at temperature of 623 Kelvin and 300 atmospheric pressure. So you watch out here, temperature is very high, that means 623. From here you subtract the 273 Kelvin, or from here you subtract the 273. In degree Celsius, you can also watch out, and temperature pressure is also 300 atm. So very high pressure is also. So under high pressure and temperature, the haloarene react here and form phenol. Actually, how the reaction takes place, about that I here guide you. In the same way, you could also solve there. Like here, this haloarene, when react with NaOH at the temperature of 623 Kelvin and 300 atmospheric pressure. What happens NaOH when react with NaOH? Then first of all, the hydrogen combine with this chlorine form HCl. So oxygen, the valency of oxygen will get destabilized and that will bond to this carbon. So there will be that is called sodium phenoxide. It is sodium phenoxide. Then after, the sodium will combine with this chlorine, form NaCl, and this hydrogen will bond to this oxygen. So compound will be there. So finally, there will be a formation of phenol. This one. Any electron withdrawing group when present at ortho position or at para position, then the presence of electron withdrawing group will ease the reaction. This one NO2 group here when present at para position, then requirement of temperature, watch out here, has been decreased very tremendously from 623 to its come 443. Here pressure 300 atm, it will take place at normal pressure and reaction will take place in the same way as I have taught you. Same, chlorine will combine with hydrogen, form HCl, ONA will be there. Then after from here Na will combine with chlorine, form HCl. So in the same way as I have discussed there, in the same way reaction will take place. When there was one electron withdrawing group, then temperature decreases very high. Then after decrease in temperature, when two electron withdrawing group will be present at the compound in haloarene, one at ortho position and one at para position here. Here NO2 group was only at para position. Now NO2 group has been bonded to the ortho position also. So there will be too much decrement in the pressure temperature. So 443 to 368 Kelvin. So temperature has decreased very high, and then after reaction takes place as that was taking place previously. That was, so electron withdrawing group, when the electron withdrawing group will bonded at ortho position or the para position, then the nucleophilic substitution reaction in haloarene will be easier. In the same way here, there are two NO2 group at ortho position and one NO2 group is at para position. So requirement of temperature will be so much less that this reaction will take place by simply warming them. So here same, that's react with NaOH in presence of water. So this reaction will take place. Now let's see here that this point is that when the electron withdrawing group will be present at ortho position or at para position, when the electron withdrawing group will be present at ortho position or at para position, then that will ease the rate of reaction. That will ease the reaction. That means rate of reaction will be fast and reaction will be easier. But if the NO2 group will be present at meta position, then the reaction, when the NO2 group will be present at meta position, then that will not affect the rate of reaction. Here, house at para position reaction is there, then house that is taking place. So electrophile approach towards this carbon atom that forms, then after through the resonance, finally this form. Same here, when NO2 will be present here at ortho position, then also finally the reaction will take place. But when NO2 group is present at meta position, there will be reaction will take place, but that will not affect the rate of reaction, because when you consider about the negative charge appears during the resonance. So electron here never come at meta position. There, when I have drawn the resonating structure, you may also watch out here, where there is NO2 group here, there the negative charge came. Like that here, NO2 is at para position, electron negative charge appears at the para position. Here also NO2 group is at ortho position, electron is at, or free electron is at ortho position. So when the electron withdrawing group, here NO2, the electron withdrawing group when present at ortho position or at para position, then that will ease the reaction. But the electron withdrawing group present at meta position will not affect the rate of reaction. Okay, that is here. Okay, that is here. Same question here. Why that is happening? Can you think why this one? So same, because during the resonance, no negative charge appears at the carbon atom where the NO2 is at the meta position. That's why the NO2 group present at meta position will not affect the rate of reaction or the ease of reaction. That was about the nucleophilic substitution reaction. Now, what here we have seen that the nucleophilic substitution reaction in haloarene is difficult, but it's not means that the nucleophilic substitution reaction in haloarene don't take place. That take place, and if there be electron withdrawing group at ortho position or at para position, that will ease the reaction. That is nucleophilic substitution reaction. Okay, that was about the nucleophilic substitution reaction. Now let's see electrophilic substitution reaction. Nucleophilic substitution reaction means the nucleophile was replacing the halogen, and in electrophilic substitution reaction, the electrophile will substitute the hydrogen here. In case of haloarene, the electrophile will substitute the hydrogen. Okay, so there, when you have drawn the resonating structure of haloarene, when you have drawn the resonating structure in haloarene, then you have observed that there was electron, free electron. There was free electron at ortho position and at para position. So electrophile means which wants the electron, that will attracted either towards the ortho position or at para position. So here, as for example, when halogenation is doing, chlorine is reacting with and in presence of FeCl3. Here FeCl3 in presence of any Lewis acid. FeCl3 here is a Lewis acid because the iron contain the vacant d orbital. The iron contain vacant d orbital. So this one chlorine of this chlorine here. So let's see what has happened. FeCl3 here. There is chlorine, this chlorine. This chlorine atom will take the electron of itself as well as the electron of this chlorine also. So this Cl minus, that will become Cl minus. That will combine to FeCl3, and that, so there will be a formation of chlorine positively charged, the electrophile chlorine and FeCl4 minus. This electrophile will bond to the carbon of para position or of ortho position. So here is, suppose this one, chlorine here, the electrophile Cl plus, that will approach toward this carbon. Here is also hydrogen here. Everywhere there is hydrogen. So the Cl plus electrophile Cl plus will attract towards this the para position. So here will be positive charge. Now, then after this, to neutralize this carbon here, this carbon will take the pi electron here, this shared pair of electron. So it will release H plus ion. So finally there will be formation of here chlorine here chlorine. This will form. Now the H plus ion released, this H plus ion will combine with this FeCl4 minus. So this H plus will combine with this FeCl4 minus. So there will be formation of FeCl3 and HCl. So the catalyst FeCl3, which was involved in the first step, that has been regenerated also. That means FeCl3 will not consume during the reaction. So overall reaction is the chlorobenzene reacts with chlorine in presence of anhydrous FeCl3. On the place of anhydrous FeCl3, there may be any other Lewis acid also. So in short, because when you will do the reactions for the NEET examination or for main examination, there will be a lots of reaction. So how much reactions you could mugged up. So better here, so understand here, try to fix in the mind that how the reaction is taking place. So in place of the catalyst anhydrous FeCl3, any other catalyst, any other Lewis acid can also be taken as a catalyst. Okay, that's keep in your mind. So in presence of the Lewis acid, any Lewis acid, here the anhydrous FeCl3, the chlorohaloarene will react with chlorine and form para-chlorobenzene and orthochlorobenzene. Same as here, that can attract towards the ortho position also, and as the reaction was taking place, in the same manner reaction will take place. So what happened here? So there is 1,2-dichlorobenzene here, and here is 1,4-dichlorobenzene. This structure is more symmetrical, so it will be the major product. So para substituted product is more symmetrical. That's why para substituted product will be the major product. So here that's why 1,4-dichlorobenzene will be the major product. Here this one. Okay. Now let's see. Now proceed for the next reaction. Next one is nitration. Nitration means HNO3 will have to react. How does that react? Just let's see here. About the mechanism also I am telling you, so that in the examination of, particularly in main examination, if reactions, and there will be a lots of reactions in which you be unaware when you have studied if you will only study the NCERT book, then you will consider that you are unaware from those reactions. But when you know, when you will watch out the manner in which I am doing the reactions, then you will predict what would be the product. Okay, so in which manner I am telling you, watch out them seriously and try to practice in that manner at your home also. Let's see here. Now HNO3, how is that reaction taking place? So chlorobenzene here, HNO3 structure is like that. HNO3 is like that. H2SO4 here taken as a catalyst. What is actually here? H2SO4 dissociates into H plus and HSO4 minus. The first dissociation constant of H2SO4 is very large, that is more than 10. And the second dissociation constant of H2SO4 is less than 100, 10 to the power minus 2. So you may consider that what the difference in the dissociation constant of first and second in case of H2SO4. So H plus here, this H plus will combine with this OH minus form H2O. So here will be, so H plus is coming here. So oxygen will take its own electron, one electron to H plus, and through other electron it will do bond formation. So it will take the electron of this nitrogen also. So during that course, the oxygen will take the electron of its own as well as that of NO2 also. So this will convert into NO2 plus and here H2O. This NO2 plus will go either to the ortho position or at para position. So compound will be here hydrogen, there is positive charge. Now to neutralize this one, the hydrocarbon takes the electron of H plus. So the compound will become here. In first case, I have shown you at the ortho position, meta position, and here same happen in ortho position. And H plus released. This H plus will again combine with HSO4 minus. This H plus ion released will again combine with HSO4 minus, and there will be a formation of H2SO4. So H2SO4, which has provided initially the H plus ion, that got again H plus and acted, that's why the H2SO4 acted as catalyst. During that course, reaction took place. Okay, so that is here in the manner in which, so when you go on the here, so NO2 combined at ortho position and at para position, and para substituted product is the major product due to their symmetry, and that's why the para substituted product will be the major product. So that's why 1-chloro-4-nitrobenzene is the major product. For NO2, when we will have to write the IPAC name, then we will have to consider that for NO2 also we use prefix and not the suffix. And for halogen, already we uses the prefix. So among this one, the similarity of this halogen and that of the nitrogen, NO2, nitro group, is same. So among then, in that case, we will have to consider the alphabetical order during writing the IPAC name of the compound. So alphabetical order, C comes first, then after N. So that's why 1-chloro-4-nitrobenzene. That is the product. Reaction has to place, that is. So better if particularly to those students who are preparing for the IIT main examination, he should watch out that concept carefully. And the students who is also preparing for the 12th board examination, CUET or NEET examination, they should also consider, they should also watch out those carefully, because that will be helpful to keep this information in their mind easily. Now reaction with H2SO4. So what happened here? Same in the same way here. In case of H2SO4. Structure of H2SO4 is 2 oxygen will do double bond formation with sulfur, and the other 2 oxygen atom which is bonded to the hydrogen, that will do single bond formation, that means with sulfur. That means the oxygen atom which is not bonded to the sulfur, which is not bonded to the hydrogen, that will do double bond formation with the sulfur. So octet of this oxygen completed. The oxygen atom which is bonded to the hydrogen, that will do single bond formation with sulfur. So they are single bond. Then after here, what happened? In this case, there is an expanded octet. The sulfur, when you consider about the sulfur, there is more than 8 electrons. So it is the example of expanded octet. How the reaction take place? Like here hydrogen at ortho position or at off para position. The OH will combine with hydrogen of, in short I am telling, How in detail we have discussed already. So in short, now I am discussing. So the OH of sulfuric acid will combine with hydrogen of the ortho position or of the para position of haloarene and releases H2O. So then after this sulfur will bond to this carbon atom. So structure will be how to write the IPAC name of this compound. So here it is sulfite, SO3. So that is sulfite. And here it's chlorophenyl and hydrogen. So you may write that 2-chlorophenyl hydrogen sulfite. Or another name is 4-chlorobenzene sulfonic acid. It's the common name. Common name is 4-chlorobenzene sulfonic acid, because right now it has, even though it will have the acidic characteristic, hydrogen could release from there. So commonly it will be called 4-chlorobenzene sulfonic acid here. And here 2-chlorobenzene sulfonic acid. But IPAC name will be 2-chlorophenyl here, hydrogen and sulfite. That means this one is a sulfite. This side chlorophenyl is bonded, this side hydrogen is bonded. So that's why here 2-chlorophenyl hydrogen sulfite, and common name will be 2-chlorobenzene sulfonic acid. Clear guys? Now let's see. Very important question it is, and in CUET examination there was a question during Friedel-Crafts reaction. What's the catalyst uses? Very simple. So during Friedel-Crafts reactions, that is either alkylation or the acylation. The catalyst used are anhydrous AlCl3. During Friedel-Crafts reaction, that is alkylation or the acylation, the catalyst used are anhydrous AlCl3. So what happened here? Same anhydrous AlCl3, that is also a Lewis acid. As I have taught you in FeCl3, that was a Lewis acid. In the same way, anhydrous AlCl3, that is also a Lewis acid. But when anhydrous AlCl3 will be taken, that will act as that will be called the catalyst of Friedel-Crafts reaction. So Friedel-Crafts catalyst, anhydrous AlCl3 is Friedel-Crafts catalyst. FeCl3, that was not specified. So same here, because here this chlorine, in short I am telling, not in detail, as I have already taught you in detail. So what happened here, this chlorine atom will take the electron of its own as well as of the carbon atom. That will combine with anhydrous AlCl3 and that will become AlCl4 minus. And the alkyl part, that will combine with either ortho position or at para position. Hydrogen released, that hydrogen released from this position or this position, that will combine with AlCl4 minus and form AlCl3 and HCl. So when the haloalkane will be treated with haloarene, then the alkyl part will bond to the ortho position or at para position. So at ortho position, alkyl part has been bonded, and here para position, the alkyl part has been bonded. How to write the IPAC name? Here C, this one M. So 1-chloro-2-methyl-benzene. Okay. Now let's see Friedel-Crafts acylation. So during the Friedel-Crafts alkylation or in the Friedel-Crafts alkylation, the catalyst used are anhydrous AlCl3. So same here, in the same manner here, a structure of acyl halide is like that. A structure of acyl halide is here CH3, C double bond O Cl here. This one. Let's see, anhydrous AlCl3 is there. Same chlorine will take the electron of its own as well as of this acylic carbon atom. So this Cl minus will combine with AlCl3, that become AlCl4 minus. So there will be the electrophile CH3 C double bond O plus. This will be the electrophile, and AlCl4 minus will be the other product. Now this will combine with ortho position or at para position. This electrophile will bond. So how's this carbon will get bonded here? So along with this carbon, there is methyl bonded. So that's why this carbon getting bonded to one oxygen, and here methyl. So that's why this is the compound here. And H plus released from here, that will combine with the AlCl4 minus. The H plus released from this position or of this position, that will combine with AlCl4 minus and form HCl, and the AlCl3 get released. So that's why anhydrous AlCl3 here has acted as a catalyst. This one here. So how to write the IPAC name of this compound? Let's see. So what happened? Open chain compound is containing the functional group. In this compound, first one I am doing, second you do by yourself. In the open chain compound, there is a functional group, and we know that when the open chain compound, open chain will contain the functional group, then the name of the compound will be based on the open chain, and the cyclic group will act as substituent. So here the name of the compound will be 1 here 2. This side is also carbon, so that's why it's ketone. Here acylic carbon atom, to the both side of the acylic carbon atom there is carbon. So that's why this compound will be considered as ketone. So name of the compound of this ketone, there is 2 carbon. This ketone is made up of 2 carbon. So that's why it will be called ethanone. Okay, it's called common name here. I am telling you IPAC name. So it will be here 1, 2. So ethanone will be the this one main name, and this will be considered as substituent, of which the benzene is the main substituent and chlorine is sub-substituent. So then after you have to do the numbering of that also. So carbon atom of benzene, which is bonded to the acylic carbon, the carbon atom of benzene that is bonded to this carbon, that will get first position, it will be second position. So it is 2-chlorophenyl. So IPAC name of this compound will be at first position there is 2-chlorophenyl, then after ethanone. Guys, the IPAC nomenclature about which I am guiding you, watch out this one seriously, because in the examination this will be also in your option and this will be also in your option, and particularly in IIT main examination, both that will be also and that will be also. So you have to consider that this compound, that means 2-chloroacetophenone, that is the common name, but IPAC name is 1 inside the bracket 2-chlorophenyl ethanol. This one is the IPAC name. IPAC name of that compound you do by yourself. Now let's see about this question. Read the question firstly. Question is, chlorine is electron withdrawing group, but it is ortho para directing Y. So what is here? I have told you that when you will draw the resonance structure, then you will find out there is 3 lone pair of electron at the chlorine atom. There is 3 lone pair of electron at the chlorine atom. So that's why it will involve their electron in the resonance. It will involve in their electron in the resonance. So electron cloud density at the ortho position and at para position, that will increase, and therefore the electrophile will approach towards ortho position or at the para position. That's the reason here. Although the chlorine is a highly electronegative element, even though when that reacts there, even though that is a ortho-para substituting group. Why? Okay, due to the presence of 3 lone pair of electron at the chlorine, that the electron cloud density at the ortho position as well as at para position increases, and that's why chlorine is ortho-para directing group, even though it is highly electronegative element. Now let's see. That was about the nucleophilic substitution reaction and electrophilic substitution reaction. Next one is reaction with metals. So like that, there was a reaction with sodium. That was Wurtz reaction. And when there will be the reaction of sodium with haloarene, that will be called Fittig reaction. Fittig reaction. Same here, this chlorine. Suppose any other compound here, this one, and like that there will be another haloarene will be also. So this halogen, this sodium and this halogen, any other X halogen, that will combine and form 2 moles of NaX. And this bond valency of this carbon atom become destabilized and that of this carbon will destabilize. So this carbon and this carbon will get bond together. That get bonded and that is diphenyl will form. Diphenyl. And guys, this diphenyl is also IPAC name. Okay, so that is here diphenyl. Now let's say a Wurtz-Fittig reaction. Wurtz for haloalkane when you have taken, when you will take, then that will be Wurtz reaction, and Fittig when you take haloarene. So Wurtz reaction, that haloalkane you have taken, so Wurtz, and haloarene you have taken, so Fittig. So haloalkane and haloarene both will react with sodium. Then what will happen? This halogen will combine with 2 moles of sodium. So there will be formation of 2 moles of NaX, and this the valency of carbon atom to which here halogen is bonded, that will get destabilized, that will bond to this carbon. So that's why this halogen, this alkyl part will bond to this carbon. That is forming. Okay guys, very easy. Now let's see about these questions. This question very easy, you do by yourself. That is your homework that you do at your home by yourself. And I hope anyone will not feel any difficulty. I hope anyone will not feel any difficulty. They will solve these questions very comfortably. So that's why this question I am not solving. Now let's see about these questions. SN1 reaction here, that is also very easy. You have to consider about the stability of carbocation. Here you have to consider about the static hindrance. About this reaction I am solving here, but a number of students, the students who have listened my lecture seriously, they could solve this question. But even though I am solving, because maybe some students not be confident, even though they have listened my lecture seriously, but maybe they may not feel comfortable, confident. So I am solving this question. Let's see here. Haloarene when react with magnesium in presence of diether. So what I have told you, that magnesium will get bonded to this carbon atom, and to with that carbon atom the halogen will get bonded. So A will be what? Watch out this reaction here. This is cyclohexane, not the benzene. When it will react with magnesium. So what happened? Magnesium will come here. So magnesium will do covalent bonding with this carbon. Magnesium will do covalent bonding with this carbon here. And with that magnesium will be bonded the bromine. So structure will be here, magnesium will be bonded to this carbon bonded, and here Br minus is that. So A is this compound. Now that is has been treated with water. So B will be what? This will be A. B will be what? When that will be treated with water. So here you know H2O that is containing H plus and the OH minus ion. In water there is H plus and the OH minus. So this compound here then treated with water. So there will be H plus and water will dissociate into H plus and OH minus ion, of which magnesium is a positive metal. Magnesium is a metal. Bond will dissociate between here because this is bond is ionic bond. Covalent bond. Bonding between this carbon and magnesium is here, that will dissociate. So magnesium will combine with this OH. So compound become MgBrOH. And this hydrogen will get bonded to this carbon. So this carbon here. So B will be cyclohexane. Okay. About that, I have also told that during the preparation of Grignard reagent, there should not be traces of water, because the Grignard reagent so formed will react with water and there will be a formation of alkane. Here is cyclohexane, so there is a reaction of cyclohexyl bromide or bromocyclohexane. Then there is formation of a Grignard reagent, that is cyclohexyl magnesium cyclohexyl bromide. That's form, and that means reacted with water. So there is formation of cyclohexane. There is a formation of that is there is formation of cycloalkane. That is, so this reaction. Now second reaction you do by yourself. Difference is that because what's here, D is deuterium, that is the isotope of hydrogen. So both will have same chemical properties. Deuterium is the isotropic form of hydrogen. Hydrogen means that is protium here, protium. So what happened here? Deuterium is also the isotope of hydrogen, protium. So that is here same chemical properties. So this one you can do. Okay. Now let's see here. When about this compound, you have to predict all of them. So just watch out during the Wolff reaction what was happening from the carbon atom to which, that means the carbon atom to which the halogen was bonded, that was dissociated, and the carbon atom to which the halogen was bonded, they got bonded together. That means the alkane here has been formed if you divide them into two equal parts. So that will be the haloalkane. So haloalkane will be here. So if you attach this carbon here, attach bromine or halogen, any other halogen, whatever be that, bromine or any halogen. So that will be called, this one will be the haloalkane. In the same way here also. So a structure of that alkyl will be CH3. Haloalkane will be that. Oh. So R is this one, that is tertiary butyl. R is tertiary butyl. What is that? That is alkyl part. So this one here, and now magnesium will react. So structure is like this. When magnesium react there, so magnesium will come here. So product will be that's the Grignard reagent. So the Grignard reagent, that means D will be that much. Now when it will be treated with water, when it will treated with water, so it will dissociate it to H plus and the OH minus. So OH minus ion will combine with the magnesium and the hydrogen will combine to this carbon. So structure will be so what is the big name? 2-methyl butane. Common name, 2-methyl propane, and common name will be here. Common name will be isobutane. So that will form. E will be that. I hope now everyone have realized that this question was easy in the real sense. that was about, those points were about the reactions of haloarene. The haloarene, we are showing three types of reactions. That was nucleophilic substitution reaction, electrophilic substitution reaction, reaction with metals. Now there is here some compounds which has some relevancy. So better you will also study here by this one line by line. But what's the important point? That means from which portions questions was asked about those points I am discussing. So let's see here. First one is dichloromethane. Dichloromethane means two chlorine will be there and that is of main one carbon. Dichloromethane means here one carbon here and two chlorine here. So remaining two hydrogen, or you can write CH2, Cl2. That is here. So what is used? It is act as a solvent, as paint remover. Wherever there is paint, when you will take this dichloromethane, then the dichloromethane will dissolve that paint in itself. So your clothes or that means your goods will become stain free. So that is first one. This one is as a solvent, as a paint remover. So it is used as a metal cleaning and finishing solvent. What is here? Everyone have the negative. That means whatever here chlorine compound, approximately all of them has adverse effect on the human health. So here it affects the central nervous system. Okay, that is about the dichloromethane or methyl chloride. Then after is trichloromethane, or that is also called chloroform. And here the most important point about the chloroform or the trichloromethane is that when the trichloromethane comes in contact with oxygen, then in presence of sunlight, the trichloromethane gives formation of phosgene, COCl2. The two chlorine atom removed from here, that will combine with chlorine. So two chlorine atom removed from here and their oxygen get attached. So there will be formation of phosgene. It is also poisonous. So here trichloromethane stored in dark colored bottle, because when the trichloromethane, also called chloroform, because when trichloromethane exposed in the air or exposed in the air, then it comes in contact with oxygen and react with oxygen in presence of sunlight to give a poisonous gas phosgene. So that's the reason the dichloromethane keeps in the dark colored bottle, as that was taking place as there be also in hydrogen peroxide. But hydrogen peroxide, that was not poisonous here, but phosgene here form, that is poisonous. So dichloromethane keeps in dark colored bottle so that it could not comes in contact with oxygen and form the phosgene, which is a poisonous gas. And chloroform was initially used as an anesthesia, but after that, since there be adverse effect of the chloroform on the human health, particularly on central nervous system, that's why now the use of chloroform has been banned. Nowadays there is a number of substitute of the chloroform as an anesthesia, and this point is very important, that when chloroforms comes in contact with oxygen, then in presence of oxygen it reacts with oxygen, and then in presence of sunlight the chloroform react with oxygen in presence of sunlight and form a poisonous gas phosgene, whose formula is COCl2. Then after is triiodomethane, that can be written as CHI3, that is also called triiodomethane or iodoform, CHI3. So its use was here, the use of triiodomethane was antiseptic. The iodoform was used as an antiseptic, but it has objectionable smell. So that's why, and it has been found out that the antiseptic property of the iodoform is due to the iodine, that is I2, because iodoform dissociates into I2, and that's then after it acts as then after it possesses the antiseptic property, and since iodoform has objectionable smell, that's why nowadays iodine directly uses as an antiseptic. Then after is CCl4. CCl4, it's used, there CCl4, tetrachloromethane, means CCl4. Now it was used to prepare CF2Cl2. CF2Cl2 that was, and also as refrigerants and propellants for aerosol cans. And here also, when it exposed, that means if anyone will continuously use the tetrachloromethane, then that there will be liver cancer in that human beings. Then after is freon, CF2Cl2. About CF2Cl2, there is a number of times, and this from the CF2Cl2. Not only in IIT Main or Advanced this question was asked, that was also asked in civil services examination about the here freon, CF2Cl2, that is freon 12 CF2Cl2, that is used, this CF2Cl2, it is used as a coolant in the refrigerator and the air conditioner. In AC, this CF2Cl2 is used, and in addition to that AC, in the refrigerator, in your fridge, this CF2Cl2, that is freon, are uses, and this CF2Cl2 that causes depletion of ozone. So this CF2Cl2 causes depletion of ozone, that is fluorocarbon, that is also called chlorofluorocarbon or freon. So in the examination, this one is very, very important for you who is preparing for IIT Main, JEE, CUET, as well as for 12th board examination. In addition to that, from here the question also asks which in the examination, which is based on the graduation level. So that's from here, that is quite important. Now let's see about the DDT. DDT, the name is dichloro-diphenyl trichloroethane. That is, and this DDT was used as insecticide. Here also you might have heard that in the municipalities in the developing countries, and about those developing countries in which the per capita income is not high, in those countries also the DDT are uses nowadays also. But this DDT drawbacks is that this DDT is non-biodegradable. That means in the environment it don't degrades, so it will get burden in the ecosystem. This DDT, dichloro-diphenyl trichloroethane, and in the developed countries the use of DDT has been banned. But in few countries also, particularly in the developing countries in which the per capita income is not high, this DDT are uses nowadays also. You might have heard about that. How to draw the structure of DDT? Let's see here. Dichloro-diphenyl here. So that means dichloro-diphenyl means there will be two phenyl group. So two phenyl group, and there will be two chlorine. So here chlorine, here chlorine. So dichloro-diphenyl here, and trichloroethane means here there will be ethane in which there will be 3 carbon atom bonded to the open chain. So this one here, this group here, if not right, then all hydrogen. It's already understood that it is hydrogen. So it is the structure of DDT. Okay guys, that was here. But this portion I have taught from only about those portions from which the question asks frequently. But if you will study these topics by yourself line by line and a number of times, then that will be more clear for you. And in future, the question which has not been asked, and but if that will ask, that means the question which has not been asked previously, but in future if the question will ask from there, then you could solve that question. Okay, so better you study this topic, polyhalogen compounds, this topic by yourself also. And even though if there be any problem you face, then already Educate YouTube channel is always willing to help you. Okay, that was about this one. Now let's see about the questions of exercise. Now this question here, these questions about which I shall consider that this question anyone will feel difficulty. Guys, frankly speaking, I'm you that of the questions of exercise, only I shall discuss about those questions about which I will consider that few students will get difficulty. About those questions I shall discuss, but the questions which are very easy and I have taught you in detail, about that I shall leave to you. I shall reply only to those guys who will feel difficulty. By considering that maybe few students have faced difficulty, but about those questions about which I shall consider that there is no any tricks in that topics, in that questions, about that questions I shall not discuss, I shall leave on you. Okay guys, now let's see here. First question here, this question very easy, I have discussed you. IPAC nomenclature, one questions I am solving. This question I shall solve, and yes, only this question. So listen here, what is here? Here is CCl3 whole thrice in the bracket. Here, this one. So that means their main carbon is this one. Here is a chlorine attached. Here is attached this. Here 1. Then after 2. Here 3. So how to write the IPAC name? This will be the main chain. Now consider about the substituent. This substituent, that means 3 chlorine here, 1 chlorine here, this 3 chlorine here. And here this one is trichloromethyl. This one is trichloromethyl. So name of the compound will be here 1, 2, 3 will be the numbering. So 1, 1, 1. Then after 2, then after 3, 3, 3. How much? 1, 2, 3, 4, 5, 6, 7. So septa. Septachloro. Then after second position, it is trichloromethyl. So at second position, you may write 1, 1, 1 trichloromethyl. And then after mention is of 3 carbon, so propane. In this question might be few students will feel difficulty, so that's why I have discussed this question. Remaining questions are very easy, but even though I am always ready, the team of Educate YouTube channel is always ready to help you. Condition is that if you are serious about your career, then Team Educate is always with you. Now let's see. Highest dipole moment, about that you must watch out. CCl4, that means CCl4 will be not CSCl3. Why? The structure will be here tetrahedral geometry. In case of CCl4, from the 4 side chlorine will come, so that not CSCl3. This question do by yourself. Preparation I have taught you already. I have taught. How much easy question it is? Need to help here. So if in these cases anyone feel difficulty, then watch out the books, watch out the videos which I have taught. This one also. About these questions, I shall also discuss about this question when I shall teach you till amine, when you will watch out all the amines till amine, then after I shall tell you about how to conversion also. A number of questions you could solve, maybe at 1-2 places, some few students will get difficulty. So better you will have to watch out the videos till amine and then after so try to solve this question. Here explain, I have taught you in detail. Here major organic product. Need to watch out the videos, very easily you could solve. This one here also, there is nothing in these questions. Mechanism of reactions, that will not ask in the examination. This question is not important for your 12th board examination, nor neither for 12th, nor for IIT main, advanced, or for the NEET examination. So that's why I am leaving these questions. These questions I am not telling that I have taught you, but this question don't ask in the examination. So that's why I am not discussing this question. Watch out this question. Very easy. SN1, SN2, how much detail I have taught you? Why this one and this one? Which will help? So SN through SN1 what? Here, and SN2 this one. Through SN2, SN1 mechanism, this will get hydrolyzed easily, and through SN1 this will get hydrolyzed easily. Very easy it is. This conversion I will teach you, but this one I am right now I am not teaching. You watch out after watching this one, these questions here. After watching the videos till amine, then after you could solve that questions. This question also. Yes, this question also you got out there. What happens when about that questions? Watch out the reactions here. Like one questions I am solving here. Normal butyl chloride treated with alcoholic UH. So about that one, already I have taught you, but maybe you feel not comfortable. So one part I am solving, remaining part you solve. So normal butyl chloride treated with alcoholic UH. About that reaction I have taught you, when aqueous KOH will be taken, then there will be nucleophilic substitution reaction. When haloalkane will be treated with aqueous KOH, then there will be nucleophilic substitution reaction. And when that will be treated with alcoholic KOH, there will be elimination reaction. So here this chlorine will combine with hydrogen of this beta carbon. So one hydrogen will release from this carbon and chlorine will release. So there will be formation of HCl and double bond will form between this carbon and this carbon. So copper become. This is remaining question you solve by yourself. If you have faced the difficulty, watch the video once again, or twice, and then after try to solve. These questions are very easy. Only two types of questions, 1 or 2 types of questions you could solve after watching the whole video from this one to amine. That means after watching the whole video, approximately whole videos of the organic chemistry, then after you could solve this question. Okay, so it's all for this class. Thank you, Team Educate.